everyone. So this is the first SF Ruby conference. Who's excited about that? Come on, more. I love that energy. That's perfect before I put you all to sleep with my talk about assets. So I have a few disclaimers. I've been wrangling assets for the past 9 years in Rails and Gems, and I still have to reference my past tweets, code, and some other articles, because sometimes it's mind-numbing. So this talk should be a little bit of an encyclopedia about why we do some things and how we can fix them. And if you think I said something smart, you can just clap a little bit and say, wow, that's awesome. And the second disclaimer is that towards the end of the talk, I'm going to go into a few unorthodox approaches. I don't want you to use them necessarily, but I want you to know about them. So we're going to talk about all of these. They sound like a lot, but my goal for today is to keep an adequate level of whelmage. I don't want to overwhelm you, but not underwhelm you either. I want to keep it somewhere in the middle. In case you're wondering why I'm talking about this, so I started development since before 2010, so I caught the early days of asset management. I came to Rails in about 2016, and I had questions about what's an asset pipeline, what does it do, how does it work, can we not use it and just go back to what we had? Then I built an engine, a distributed engine, and I've hit a lot of problems. And then I built a little bit more, I made a little bit more open source work, and again, I hit some more problems. So yeah, this is me, Adrian. You'll find me, Adrian the Dev, everywhere, online. I also co-hosted a small boutique conference in Europe called Friendly RB. So what are assets? So mainly JavaScript, CSS, images, SVGs, JSON, like the list goes on. We'll focus a lot on JavaScript today because I think that's the gnarliest part of them all. How did we used to do it before? So we would do something like this. We would load jQuery and then jQuery plugins, and then our own plugins, and then maybe vars.js, and then main to actually initialize everything. And everything was global on the screen. This is past code of mine. Don't judge me. And everything was global. We can go in the console in the browser and actually see what those variables were, or like run methods. And it was quite nice to do that. But that came with a few problems. Some of those problems are solved by our asset pipeline. And one of them is actually bundling, which is a fancy word for concatenation. We quickly figured out that if we have many scripts on our page, the browser has to do many requests, and HTTP1 had a problem. It had to do a lot of handshakes back and forth, and the browsers weren't very good at parallelizing all of these requests. So we kind of figured out, okay, why don't we put everything in one file? And tools like Grunt and Gulp and Broccoli came along, what they would do is actually go through all of our files and just put everything in one JavaScript file. They would have like task files, kind of like these ones. And then we figured out, like, hey, we have one file. Why load it again and again at every page load? Why not cache it? Because the browsers are very good at that thing. So the browsers can cache it, but what happens when we change them? We need to bust that cache. And hence, this is how fingerprinting came along. And how the asset pipeline does it is actually it goes through all of the files which you expose to the public. It gets all the content. It creates a unique hash for them. So instead of asking from the server, like, give me application.js, it'll do application dash the unique code.js. And then we can cache that for about a year. I think it's the default in Rails. And then when we deploy again and we change the content, the hash is a new one, so the cache is busted for us. And another helpful thing that the asset pipeline helps us with is transpilation, which again is a fancy word of like, take this code, pass it through a function, update it, and then put it out there public. And some common use cases for transpilations were Sass to CSS, CoffeeScript to JavaScript, adding vendor prefixes, minifying scripts, maybe even optimizing images and SVGs. Sprockets did all of that for us, and as the web evolved, it had to do more and more things. So if we check out some of these transpilers, it had to do like Babel and then Clojure and Zopfli, whatever that is, and it became more and more like a bigger package. where are we now? So we have HTTP 2, which solved those handshake problems, and having multiple connections, the browsers are way smarter now. CSS became smarter. We don't need Sass that much anymore. JavaScript became smarter, so we don't need CoffeeScript. So in 2021, 2022, David started working on PropShaft, and PropShaft is a mostly drop-in replacement for Sprockets. It does only 4 things. It runs a dev server, fingerprinting, it does just a little bit of transpiling, if you need to, and adds a configurable load path, which is fancy for like, hey, watch this folder for me. Front-end got even better. We got import maps, ES bundling, and JavaScript, JS bundling, and CSS bundling. Import maps is a rather new technology where you can throw the browser a list of files, like this hash, and then you can use the fancy import statement, and it knows where to fetch it from. And that's important because you don't need a build step, and you can use modern JavaScript. If you're wondering how import maps works with PropShaft, it's actually really easy. Import maps requests files from the server, and PropShaft delivers them. Radan Skoric has a nice article about it, so if you want to check out, do you want to see more, you can check out his article. JS bundling and CSS bundling. For CSS, these are essentially tools, other processes, other packages which bridge the gap between what Sprockets used to do and PropShaft doesn't. So instead of having something in Ruby to actually bundle JavaScript or CSS, we actually use these libraries here which do it much, much better than we could do it in Ruby. There are other tools out there, like Shakapacker, which is a fork of Webpacker. It's maintained by a third party. And we have Vite Rails, which is kind of amazing. It takes a different approach where it does everything for you, from like bundling and dev server and doing a lot of really, really cool stuff. SVGs, I haven't talked a lot about them because you just need to use this gem. It will inline SVGs, and it will enable you to customize them however you want through styles and classes. So we have an overview. We have 2 asset pipelines, Sprockets and PropShaft. PropShaft is the new one, so just use that one. Bundling tools, JS bundling, CSS bundling, import maps-ish, and Vite Rails. JavaScript can be served by PropShaft, import maps, or Vite Rails. CSS can be served by by PropShaft and Vite Rails. If you want to move fast, you use PropShaft and import maps. If you need a little bit more power, you use PropShaft, JS bundling, and CSS bundling. And if you need a little bit of elegance, you can use Vite Rails. That's it, folks. Was it that easy? Let's go. No, it actually wasn't that easy. It was quite complex and mind-numbing at times. But actually, it's cool that we have all of these at our disposal. We have the tools to build whatever we need. And if we keep to the guardrails, we'll be just fine. I mean, there are other bigger problems in the JavaScript world which we don't really have. So let's get to the real talk to see how we can leverage the asset pipeline to build Rails plugins effectively. And more importantly, is it easy? Is it not easy? Not easy? Do we have one way of doing it? Do we have more ways? So what are we building? So a while back, Jeremy, my buddy, he launched Liminal, which is a new take on forums, and he had this amazing Markdown editor on his website. And I asked him, "Is this a library? Can I use it?" He said, "No." I said, "Can I build it?" He said, "Yes," and that's perfect. And then this is how MarkSmith came along. So it's an MIT licensed Markdown editor. Just like GitHub's, it works with active storage, just plugs into any Rails app, and it's quite amazing. So we're gonna, do you think it's a coincidence that Jeremy's last name is Smith, and this is called MarkSmith? I guess we'll never know. So we're gonna build ComSmith. Actually, we're not gonna build it, but we're gonna have a look at the complexities of actually building an engine and packing it all together into a gem. So let's take it from simple to complex. And why? Because there are some requirements if you want to cover the whole spectrum, because we don't have just one idea, one way of doing assets in Rails. We actually have quite a few ways of doing it, and there are a few requirements and a few decisions to make. So the lowest hanging fruit that you can do is use import map, because you don't need a build step, and you can use it in any modern Rails app. These two updates will make the consmith.js file available to the parent app. We first create an import map RB file in our gem, and then we tell through the engine file to the main app, like, hey, use this import map RB file. And then we need to tell Sprockets to actually watch that directory, the app.java/JavaScript directory for us. And then the main app knows about it. We ticked off 2 boxes. But what if we need a little bit more power? What if we need NPM packages in what we ship? So we have 2 ways of doing it. One is we can bundle it ourselves. So inside our gem, we install import maps. And then we pin the dependency inside our gem. Then we tell, again, the main app, we tell it to watch that vendor JavaScript directory, which import maps creates in our gem. Then, through that whole configuration, the import map RB file is going to be available to the main app whenever it has our gem installed. The second way of doing it is a little bit easier. You just tell the user to pin it in their apps. It's easier for you, but again, it's a game of balance, depending on what you need to do. So you use the first solution if you want to make it more streamlined for the user. They don't have to do anything. But you use the second solution if this is a very common dependency. So for example, they might use the confetti package in their main app, and you don't want conflicts between versions, between their version and our version, and you just pass them the responsibility to actually install it. We're ticking off a few more boxes off of our requirements list. But what if we need a little bit more power? We need to do some TypeScript, some JSX compiling, or if we need a little other features which are a little bit more modern in JavaScript. We said we don't want to have a build step inside the main app, but that doesn't stop us from having a build step inside our gem. So we're going to install esbuild. We're going to build the gem. This is mostly out of the box. And we're going to have this consmith.js file in our app assets builds directory. It's all packed up with everything we need. And then we can also remove these 2 little bits from our engine file, because it doesn't, now we don't have to watch that app JavaScript directory and the vendor directory that we used before, because ProfShaft automatically watches our builds directory for any engine. And we ticked off a few more boxes. So import maps are great, but not everybody's using them. So maybe the parent app is using JS bundling, and maybe it was configured with JavaScript like this, with the JavaScript flag like this, like esbuild. And then maybe the user would just want to use our package just like that, like import consmith. Unfortunately, that's not possible. Even though PropShaft exposes the consmith.js file through the engine, esbuild is a separate process. It doesn't know about that. So we can do a few things to make that work. So the first solution is creating an NPM package. And you might think it's a heavy lift. Like, why should I create an NPM package when I already have a gem? And why should I publish it and keep 2 things? Well, it's actually one of the most common ways of doing this kind of thing. And it's not that difficult. You do yarn init, and you're going to get this package.json file. Just hit enter, enter, enter. This package.json is kind of like your gem spec for your gem. We already have the JavaScript file compiled, so you just tell it, hey, use that one whenever you publish. You run npm publish, and then it's up on npmjs.org. Then you just tell your user, just add it through yarn, and then use it inside your app. And now we ticked off even more boxes. And this is a setup which will last us forever and ever, or at least until we have another gem that will have another asset pipeline, then we'll figure it out. So I told you about a few unorthodox approaches, and I want to just show them to you. I don't want you to use them, but it's good to know about them. So first of all, if you don't want to do all of that dance, you can create a rake task that the user just runs, and it'll go inside your engine, pick up that JavaScript file and copy it inside the main app. And then the user uses it like any other JavaScript file. This is great because it's easy, but it's not that great because they have to do it, and they have to do it every time they do a bundle update because it's not going to be updated automatically. The second thing you can do is use a symlink. So it's similar to that one. It's a little bit better because it keeps the JavaScript file in sync. So if you update it when you do a bundle update, they're going to get the latest version. But they have to do it in the CI system, and whenever they deploy, they have to symlink. So again, it's not perfect. You can inject the file yourself. So using a snippet like this, like JavaScript include tag, that will be available in the DOM because ProfShaft, made it available from the app assets builds directory. It's not perfect because, like for example, if you want to expose a stimulus controller, that's not going to be able to automatically hook into your stimulus instance where you have the rest of your controllers. You can do a few things. I have here a few links from how we do it in Avo, and I'm going to show it in just a second. This is a little bit of pseudocode. So what we do inside our application HTML, we create this array of stimulus controllers. Through a plugin system, we inject the JavaScript tag for that controller, and then inside that array, we kind of register. It's not registering, but keeping track of that controllers. And somewhere in our application, we actually register the controllers that we injected to the main app. And then we do whatever else we do in our application. And this is a very important thing because when we ship Marksmith, for example, the user, the only thing they have to do is do bundle update, and they will get the fresh version of the JavaScript file as well. They don't have to do anything else. And that's a huge flex in the library building space. When we built Avo the first time, that was 2020. That was kind of the high of Webpacker, and there were kind of two camps where some people were using it, and it was kind of difficult. They had like 1 minute, 2 minute, 5 minute, 10 minute kind of build steps, and some people didn't want to use it at all. And what we wanted to do is ship this engine, but not upset the people that weren't using it, right? So there were people that didn't have Node on their server. And we wanted not to upset them and to be able to use Avo freely. So what we did, we came up with a different solution. We used a middleware. So whenever we built our scripts, we built them inside our public/Avo assets directory, which is not public whenever you deploy. This is somewhere in vendor, bundler, vendor directory, wherever it's hidden. But we, through the engine, we expose that path using a middleware. And then whenever Avo requests assets, that request goes through the middleware, and they can get to that directory. It does have some caveats that it's not going through the asset pipeline, so you don't get fingerprinting support and a few other things. But again, you're not upsetting anyone. Like everything will just work. They're going to get modern JavaScript. CSS, again, I haven't spoken a lot about it because it's easy. You just inject this CSS file and it'll just work. You can also use CSS imports. You have to use this URL method to make the paths work. So what did we learn? The asset pipeline is actually quite powerful and quite useful. Import maps is a very low-hanging fruit. esbuild is very, very powerful, and we can create like gems with perfectly delivered assets if we want to. It's a little bit of a lift, but we can do that. So if you want to talk more about assets or like gems or engines or anything else, you will find us at the Avo booth. Come join us. And thank you so much for coming to my talk.